So good morning or good afternoon, everyone. Welcome to today's session. I'd like to share my very warm welcome to everyone who's joined us today. Our presence this year at the virtual version of SmallSat started yesterday with a workshop around requirements verification test management for satellites. And today we'll actually be showing what the software Valispace actually can do and how that works. So the session today will actually be an interactive walkthrough. You'll see later today how the software works, how it looks like, and you'll have the possibility of actually asking questions to our customer success manager, who will be showing you through all the different features and the workflows that you could benefit from. Now, as a very brief introduction, I actually have a 1-minute short video to introduce what Valispace is all about. Let me know if you can hear it well or if it needs to be louder or more quiet.
What would the final velocity of the rocket be if we changed the fuel mix ratio to 4.5?
I'll get right to it. We need to find out what the final velocity would be if we changed the fuel mix ratio to 4.5.
This is a nightmare. This calculation hasn't been updated in years.
Who does even calculates in pounds per cubic foot? This value cannot be right.
This is not going to work.
The density in the draft 3 analysis, the current one.
Alexa, start Valispace.
Welcome to Valispace.
What would the final velocity of the rocket be if we change the fuel mix ratio to 4.5?
The final velocity would be 14.3 kilometers per second.
So this was a very short intro as to what Valispace is all about. And the ultimate goal of what the software offers for different types of customers that are currently using it is full traceability along the engineering lifecycle. So what do we mean by that? As a recap, essentially starting off from requirements engineering up to then designing concurrently and furthering those designs into more detailed designs and actually connecting to simulation tools all the way to reviewing, doing technical change management, and then testing on documentation, being able to really trace back where all the data come from, and then essentially storing them in a single source of truth, which Valispace then offers. I won't dive any deeper, so we can go directly into the product demo. But just to give you an idea of the types of customers that we today have in the space industry, this ranges from small organizations up to large organizations designing satellites, rockets, and any other kind of complex hardware, but also outside of the space industry in automotive, medical, and aeronautics. We are very active. About our host today, myself, I'm a space systems engineer by training. I used to work on future lunar missions at the European Space Agency and currently head of marketing at Valispace. And today I'm joined by Kawe, who's our customer success manager, also a space systems engineer by training. And as part of his role, he actually oversees all of the onboarding and training of the different customers starting to use Valispace to really benefit from the data-driven engineering methodologies that we're offering. So without further ado, let's get started. Kawe, the floor is all yours.
Oh, thanks, Stefan. Good morning, good afternoon, good evening for some of you. So I've seen that we have some people from Japan, some people from US, so we have the whole range. Let me start sharing my screen so we can dive in directly to the tool. Screen. All right, just zoom things here and open the chat and everything else. Can you see my screen, Stefan?
Yes, we can. And one note I wanted to make for all participants, since we're a very small group today, right, I'll actually promote everyone to a panelist. So you can actually immediately have the possibility to talk or interrupt or ask specific questions about the software. Of course, no pressure. But to anyone who's interested in asking questions, you'll be able to do so directly.
Yeah, and if you don't have mic or you're a bit shy to speak, you can also just write on the chat. We'll be following that. Okay, so well, Stefan already made a good introduction of Valispace. Valispace is a data-driven system engineering tool. It is a web-based platform. So we have our online version which is hosted on AWS Europe in Frankfurt. But we also have an option for the on-premise in case you want to host Valispace on your own servers and control all the firewall and all the security details if you want. But yeah, let's dive to it. Since it is online platform, is a web browser-based platform, you'll be always working on the browser. And whenever you do a change, this change will be propagated, will be sent to the server, so every other user will see the same changes directly on the tool. And Valispace is divided in modules, and each module gives you an overall perspective of the project. So let me start then making a brief description of every module. The first one is the project module, which gives you a project management perspective, as well as a overall of everything else that is going on the project in Valispace. So you do have the list of all the users, all the discussions that are going on every other module, as well as the notifications and the tasks. So tasks can be created in every module, but here you also have a timeline, so you can see how your project is going as a project manager, and the tasks, they can have dependencies, due dates, and all the typical project management features, as well as automatic rescheduling. So for example, here we have 2 tasks that depends on preliminary requirement specification. And if that get delayed, everything else will get moved along. So, and all the due dates will get warnings if something is conflicting. And all the people will also receive notifications if they are associated with that task. You can also see, for example, all the tests that you have planned on the test module. So you also have the test plan visible here on this timeline if you want to. Additionally, we also have the dashboard, for example, which shows which you can configure which data you want to display, but you can define, for example, dashboards for different subsystems or departments where your team can easily see the data, the summarized data, or the data that you think is more important for them to see every time they log in on Valispace. Right, so on the components module is where you actually do your design, your system definition. So for you that were interested on rapid concept design, but even detailed design, this is where you will do, where you define your system. So on the side here, we have the components. Every block here is what we call component. And this component can be a high level system. It can be down to a single element. It can also be logical elements like orbit or operations or the entire mission. And you can also always rearrange them, drag and drop to order the hierarchy of that component, and just simply create new components by right-clicking and adding as component directly as a child. And on the right here, we have the valleys, as we call valleys, which are the properties of each component. So you see that when I click on a different component, you can see different properties, the properties related to that specific component. And the properties, the values itself, they can be either a constant that you can say, okay, the mass of the antenna is 10 kilos, is 5 kilos, but you can also create functions. So like this, for example, where we are calculating the losses of the pointing of the antenna, we are defining it with a pointing error and the beam width and so on. The same way as you would do on an Excel, where you say, okay, cell A1 is the multiplication of cell B1 with cell D5. But in Valispace, you have the advantage that you can call those by name. So if you're calculating force, you just say, give me the mass of the system multiplied by acceleration of the system, and there you have the force. And automatically, Valispace will do all the unit calculation and conversion and, well, the dimensional analysis. Mentioning the units, for example, here we have the mass of the platform in kilos. If I just want to display that in pounds, or if I'm working with American people, for example, I can just change that to pounds, and this will be automatically converted to the corresponding unit. Properties can also be mode dependent. So here we have the power consumption that is a mode dependent value. That component platform has its own mode, which is off, standby, minimum, nominal, and maximum. And Valispace is calculating those automatically because we are using the formula sum of children, which is the same that we use on the mass. So Valispace will go on every lower level and sum up, do the roll up of all the masses of every component. So whenever someone changes the mass of a lower level, this will be propagated all the way up automatically. The same for all the mathematical relationship between the properties. Additionally, every value and also every requirement and everything else that I will be showing, we store the changes in Valispace. So for example, for the mass of the platform, we can see how that value has been evolving over time. So first we have that graph that shows the evolution of the mass, and we seem to be stabilizing around 539. And down below we have a table which shows all the changes that have been done on that property, direct or indirect change. As you can see here, we can on this example, we see that the admin in this case is the admin user, but it could be any other user. It will be saying their name here. Like for example, Stefan has changed the battery tech energy density from 300 watt-hour liter, to 125, which impacted the mass of the platform in 19 kilos, approximately 19 kilos. So you have the full traceability of what is going on your system. When we use the sum of children, Valispace also automatically generates this budget tables that you can see directly on this table, all the breakdown of masses and all the margins and the worst cases. By the way, I forgot to mention that before, but you can also assign margins to every property, and the Valispace will also handle the accumulated margin. So in this case here, the 15.82, it's all the margins that is brought all the way down to all the way up from the lower levels, that each component has their own margins. And Valispace calculates this worst case. So if we assume the worst case margin, the spacecraft will be weighing 624 kilos. We also have other features that might help you to do quick trade studies. For example, we have the alternative container, which allow you to set up different options for a specific component. In this example, we have a battery alternative container, and inside it, we have two different options. We have a lithium battery and a nickel battery. So whenever I click, I can set up all those options and define their own properties. And when I click select alternative, Valispace will recalculate everything that is associated with it. And once it is done, you will see some things flashing up here that they will be recalculated. And at the end, we will receive a pop-up saying how many values has been updated. Here we see that 120 values has been updated because we changed the battery to a different option. Right. I hope I'm not going too fast. If you think I'm going too fast, just send a message. Yeah. So we can, if you are interested, we can explore a little bit more the details on this specific module. Well, before moving to the requirement, I also want to mention that pretty much every table in Valispace or every object, they also have these collaborative features as well. So the tags, you can tag anything in Valispace. You can have multiple tags on the same and give all the color coding that you want and create custom tags. So this is a user created, as well as the tasks that I mentioned. So here we created one task that is directly related to the cost of the spacecraft. So whenever you are managing your team, you can imply what is the related object that you want that task to be executed. So this task is cross-check the value against the allocated budget. And we see that this is related to the spacecraft cost, not necessarily the antenna cost or anything else. Additionally, we also have discussions. So you can have discussions with your team directly on each object. So you can just write a discussion. You can also mark a colleague. You can use the @ sign and say, hey, Stefan, can you answer this? And then Stefan can just reply to me here. And when I'm satisfied or any question has been resolved, I change the status to resolved, and then the discussion will disappear from here. All right.
Sorry, I don't know if you can hear me.
Yeah, again. Hi, Stuart.
Hi. I just have a question about the mass margins.
Sure.
So for the roll-up, how does it work? So you had 15.82% margin, I think, for the last component. Just a random example.
Yeah.
But how do you roll up for the whole system? Like, do you have RSS, or can you change the method you use?
Yeah. So currently, by default, the margin is we're just assuming the worst cases, right? So if we go to the lowest level, I think the TTC here is a constant. Yeah. So we can, like, if I change that margin to 10%, the total margin will be 10 because this value is a constant, right? So it's the end of the roll up. We could be using sum of children, but we're not at this moment. So this 10%, we are getting this worst case 55, and this 55 is being brought all the way up. So we are recalculating the total margin according to that summing of worst cases.
So it's just a linear summation.
Yeah, we also have another method that we can set up. I'm sorry, but now I'm missing completely the name of that. Yeah, we can set up a different kind of propagation that, if I'm not wrong, like we consider this as the sigma of the error. So we do some more detailed calculation. But yeah, this linear propagation is the one that is set by default.
Okay, that's great, thanks.
Yeah, welcome. All right. Yeah, thanks, Stuart, for just showing up and asking. That's really nice. Okay, if there is no more specific question here, I can move to the requirements. And well, in the requirements module is where you do your formal requirement definition. So as we had the components on the sidebar, here we have the specifications, and specifications are a group of requirements. Ideally, you would do one specification per verifiable object, but in Valispace, you can do one single big specification and not break it down if you want to, or you can break down as much as you want. It's up to the user. But we recommend that you create one specification per subsystem and you break it down more if you want to, or if you have more requirements to break it down. But for the requirements, we have the typical requirement fields. So the identifier, a text, parent and children relationship, state, what else? Type. We have a lot of other fields for those requirements here that you can check up. And we are also on the next version to be released next week, probably. Yeah, next week. We will have the custom column, so you can define your custom fields for requirements. And as I also mentioned, the requirements, they also have history, so you will always be able to see who changed what was the change and when of the requirements. But one of the main things, or the nicest thing here, is that on the requirements, instead of just writing a text, simple text, you can create properties the same way as the components. So you can create values that are linked to that requirement. So you can reuse that later on. And if you change in one place, this will be changed everywhere else. So for example, here, the spacecraft shall have a mass less than 900 kilos. Here we created that variable that we can reuse. In comparison with this one, that is just a text. The other important concept of the requirements is that the verification method. So how exactly you are going to verify all those requirements, right? So in Valispace, one requirement can have multiple verification methods. So for example, on this requirement, we can do first an analysis or automatic verification, which I will show in a bit. And probably at the end of the project, we will do an actual test that will put the spacecraft on a scale and measure the mass, right? The weight. So that's what we have here at verification methods. The first one that I want to show is the rules, which is the automatic verification. And here we specify which component this is being verified upon. And on the closeout reference is where we say, where we define what is closing this requirement. So here we have the rule written, which is a Boolean equation. So we are comparing the mass, the actual mass that we have on the components, which is 915, with the requirement mass, which is 900. So this is automatically shown as not verified. And if someone updates something, some colleague update the mass of the battery or changed something else, the value will be recalculated automatically, and this status will also be updated automatically. So as an engineer, I will always have the visibility of if I change something, am I breaking any requirement or not? The other verification methods, they can have, for example, documents attached. If you want to attach a PDF for your analysis, CFD analysis, for example, or an image or anything else. And you can also have the manual changing of the status. And the test, you will link the closeout reference with an actual test that you define on the test module that I will show in a bit. And whenever you execute that test and is approved, the status will also change automatically. We also have some other visual representations. So for example, the connections graph show how your requirements connect to each other, what are the dependencies and breakdown. So you can see all the dependencies here. And the status that gives you a verification matrix of all the specifications and all the components and how many verifications you have per component, as well as the tree view, which gives you the same breakdown that we have on the components module. So a system breakdown with the color coding of the verification. So here is where you will do your requirement coverage analysis to see how much have you already defined as verification. So are you forgetting about any component or not? And later on the project, how far have you gone with the actual verification? So is everything verified and ready to launch or not? You can also filter out this tree if you don't want to have everything displayed, just to see, for example, just the payload or just the spacecraft. All right, any questions on the requirements before I jump to the next module? No, don't think so. Let me just do a check if I'm forgetting about something specific. Well, the requirements, you can also upload files, the same thing for the valleys. You can upload files to it, so you always have the clear reference. So for example, if you have a datasheet for the battery, you can upload that file directly to the component, so you know where to find your documentation. And well, that's it. The task discussions and the notification that I think I forgot to mention. So you can always subscribe to any object in Valispace, and whenever someone changes anything there, you will get a notification here on the sidebar saying that a user X has changed this, which impacted the object Y. So you have all of that here. All right, so the analysis module is your documentation system. So you can write your documents here with the advantage of creating live links with the properties, with the values, with the requirements, with anything else. So you see here that this 519 is actually the orbit altitude variable. And if someone changes there on the components, this will be changed automatically here. So you will always have a live or a latest version of that document generated automatically. The same thing is valid for all the graphs, all the tables, and everything else. So you can add tables for the requirements, tables for the budgets, and so on. This document, you can either download this as a PDF if you need to send it to someone, or even better, you can create a shareable link that you can share with an external provider or collaborator, and they will see the live document as well. So this will be updated automatically. It's not a frozen version of that document. Alternatively, we also have a Word plugin that allows you to do pretty much the same thing, but on the Word platform, and then you can link to Valispace and do the references. And we also have a Google Docs, which is coming up soon. All right, so before I move to the time sequence, I just want to remember that I mentioned the mode-dependent properties. So here we have the power consumption that is mode-dependent. And the time sequence module allow you to add the time variable to that system definition. So for example, you can say, okay, my satellite is operating on standby for 3 hours, and then it changes to science 1, then to science 2, then to maximum. So you can set up these scenarios, which you can do a quick evaluation of that envelope, right? This is not a replacement for a full-blown Simulink module, at least not yet. But on that topic, we also have a Matlab toolbox, which you can connect to Valispace and run all your simulation on Matlab with Valispace data. But this module is more to do this quick analysis for you to know if something might be out of bound or not. So in this scenario, we are just doing a simple mission analysis for the power consumption. Here we set up what are the conditions to change each mode. So we start on off, we change to standby, then we change to science and so on. And on the runs tab, we first have this timeline of each subsystem and their corresponding mode. So you see the spacecraft is off standby, but we can also see the related modes, like how is the EPS, how is the AOCS and so on. By the way, this color is a bit ugly. I don't have any sense of style here, but you can set your own if you want to. These ones were generated automatically, I think the 3 ones. But the ugly one I did, sorry about that. So down below, we can create variables, time-dependent variables. So here we have the power consumption that Valispace is calculating automatically according to the modes. So you can see here that we start on 0 watt, we go to 400 to 800 according to that changes in modes here. So you can see how much power consumption we are getting over time. And they accumulated the integral of that here. So you see how much you consumed in total. Down below, we are creating just a calculation of the total solar power generated. For now, we just have a constant. We are not assuming any eclipse or anything. And down below, we can calculate, for example, the battery consumption. So we have the consumption minus the solar power. It's negative because we are actually generating power. We are not consuming. But if we want to make a scenario, for example, that my solar power stopped working at a certain time, I can create a node here, say change formula of the solar power to 0 on time after 30 minutes. And I can run that calculation and see how that will impact on my power, my power profile. So let's just wait it to refresh here. We see that the values has been is updating. The solar power here should go down. So we see that we don't have power here, and we can see the battery consumption that we started now consuming power. And you can go further and do more complex calculation. We can see if we will have battery at the end of the mission, for example. And well, we are still adding a lot of features, a lot of capabilities to this module and many others. So we will have more things added here in the future. Okay, so the simulation module, it's an Octave engine running inside Valispace. If you don't know, Octave is an open source Matlab. So you can write some Matlab code here to make a bit more complex calculation to your values, to your properties. So you define properties as input. So for example, these two are inputs from the components, and output properties that are also in the components module. And here we have the calculation, how we are doing it. So in this example, it's just a convergence calculation, a while loop. So you see that you can write a little bit more complex things here to calculate. So whenever one of the inputs change, you will get a warning saying that this needs to be rerun because the input has changed. On the side note, I already mentioned that we do have a Matlab toolbox that allows you to work with Matlab and connect to Valispace. And I would also like to mention that we have a completely open API. So pretty much every data that you see and you can interact as a user, you can also do that with API. So it's quite easy and straightforward to write integrations, automations on your own with, for example, a Python script or any other language actually that you can do web requests. So for example, we've seen customers developing integrations with ANSYS, with SolidWorks, to making automations with the tags. And well, there are endless possibilities with that when you can write on your own scripts. Okay, so finally on the test module is where you can define your test procedures. So one of the closeout references that you have. So here on the sidebar, we have the test procedures that we have for our system. So a battery discharge test, a solar array, a firing test, and so on. So here we see a summary of all the tests of the test procedures. And if I go to the solar array test, we will see first the initial information, the description, who created it, who is the owner, which is important. And down below, we have the step. So step by step, how we are going to verify or to execute, sorry, how we are going to execute that test procedure. So in this simple example, we're doing first a voltage check. And to do that, we have the sub-steps of put the multimeter, connect the multimeter, the positive and the negative, and then measure the voltage. Then we are doing a current check and so on. So here you do all the definition. And the important concept or the important feature here is that you can connect a step with a requirement. So in this specific example, we have a requirement saying that the maximum voltage of the solar array, solar panel, shall not be more than 20 volts. So whenever we measure the voltage, we will check if it is not more than 20 volts. And if it is not, we pass that step. And as I mentioned, if that procedure is approved, this requirement here will automatically be verified. Or the other way around, if this we marked as failed, the requirement will be changed to not verified. Additionally, you can also mark a specific step as critical, implying that if you fail that specific step, all the test procedure will fail. And when the step is not critical, you can fail that, but still continue your test procedure. Well, and here is where you define the test procedures, and under runs is where you actually store or plan and record the test that you executed. So here we have several of executions. And for example, this one, the test run 4, you see that every time you save an execution, you also save all the test procedure, the current state. So even if you are evolving your test procedure, you will see that every run corresponding to the version of that test run you executed. So if we run first with a really simple and later we make it more complex, the first one will still start that old version. Okay, so here we have the status, so we can simply just mark it as passed, mark it as passed. And once we do this, we will have the approver. So just the approver can mark the step as approved. And once this is approved, all the status of the requirements that I mentioned will become verified, will be updated, sorry. And well, really quick and really in a nutshell, that those are the main features or the main ideas of Valispace. We can open for some questions. Let me see if there was any question. No. Oh, nice. I saw that Balaji was explaining the margins to Stuart as well. Cool. Is there any other questions? Nope. All clear. So following, we have a new feature that we're going to release this year still. It's called Review Center. So it is a feature where you can actually perform or define the objects to be reviewed. So you have that control of the review process. Hi, Marcelo. What exactly you mean by standard settings? Not sure if I understand exactly that point. Maybe the settings for the project. We do have the settings here under the user, where you have some definitions of what requirement types do you have, what requirement states do you have, and the transitions, and also the verification methods. So you can customize the verification methods that you have, as well as other settings. Oh, an important or interesting feature that we have, I forgot to mention, it's called the time machine. So since we store every change in the database, it allows us to create this feature called time machine, which allows you to compare values between 2 points in time. So for example, if I want to see how my spacecraft was at any time. So let's say, let's get some random day here, like January 20 at, well, it can be the same time. Valispace creates this comparison table. So you see that the mass at that time was 504 and currently is 520. So then I can just explore and click on every component and see that comparison. Or I can just go to list all and see the list of all values and the corresponding and their changes. The same works for the requirements as well. And the baselines that you see here, it's pretty much a bookmark in time. So you can create a baseline which a given name. So CDR, well, we already have one here, but CDR. And you can add a description and define the time. So for example, that CDR occurred on July 8 at 16. So you can save that. So you can just have a quick view of, okay, let's compare this with the CDR instead of that or a given date. Right. What else? Any other questions? How do you work on a constellation? So I would say that on a constellation, you would have one big mission, if you want, like the constellation here. We do have customers that are working on constellations. So we have people that is doing exactly that in Valispace. And the idea here is that you would have the constellation as the main level, or maybe even higher level, like a mission, and the constellation, and inside it, you would have copies of that spacecraft. So you could have multiple spacecrafts, and then you can define each per individual parameter, like the orbit plane or the phasing on that given spacecraft. And you can even use another interesting feature that is called connected copies. So every spacecraft could be a connected copy because what the connected copy does is keep those connections or those connected copies in synchrony. So whenever you change one value in any of them, these will be changed everywhere else. So you see that the solar array here is connected because they are identical. So if I change the value here from 11 to 12, these will be recalculated here and will also change on the solar array too. So this will be flashed to 12 once the calculation is done. So you see that it's already changed here and change everything else. So you could have all the satellites as connected copy if they are identical, or if you have a hybrid or a mixed constellation with different types of satellites, you can just make a simple copy and start working from it and expand that model. And if you want to make a specific property disconnected, so for example, if we want to make the area, one solar array for some reason is a bit bigger, you can disconnect here while all the other properties will be connected. And apart from just doing copies on the same project, you can also make a connected copy and move it to a different project. So what some customers do, they have a model repository project where they have all their COTS elements. So, and they make connected copies and apply them to a specific project. So if someone changes on the repository, it will be changed on every place that this object is used. And a similar idea is to copy the entire project. So you can have one template project, satellite, and just make copy of that if you want to make a new version of it, for example. And you can also reference values between projects. So maybe one idea would be to have one project that defines your satellite, the satellite for your constellation, while another project is for the constellation itself. So you can get all the properties of the satellite, but keep the constellation at one isolated system on a different project. If that makes sense for you, because it might have some extra overhead, but you will have that a bit more separated if this is necessary. So it depends. It will be case by case which one is better, the better alternative. Talking about that, I remember also the permission. So in Valispace, you can set a permission on pretty much every level. You can define the permission for the workspace, for the project, down to a specific property. So you have, if you have the cost or the mass that can only be updated by one specific engineer or by one department, you can just set the permission here, clicking on the three dots, then send permission, and you will create a custom permission. So you can make it read only or read and write for a specific person, or even no access if you want to make this not visible to other people and just for a certain group. Cool. Hey, good question. Anything else? Or maybe Stefan and Balaji, if I'm forgetting something big and important, feel free to just remember. I think we covered.
Maybe one interesting thing, Kawi, that could be valuable to share is just how to get started. So imagine if someone from the audience here today is interested in actually trying out the software and, for example, you're talking about requirements engineering. How do you get started? What are different options? For example, importing requirements or importing standards and so forth.
Good question. So when you start a new project, you will start it from scratch, an empty project, but you can simply import. For example, if you have a table in Excel with all the requirements, you can, sorry, not here, here. You can import your requirements from a file, an Excel or CSV, or even import from doors if you have it. And if you want to go on a fancy, complex way, you can also use the scripting to import your data. For example, we do a lot of work with our customers to import their complex Excel data into Valispace with some scripting. Yep, that's a good way to get started. And if you are interested, you can do a 2-week trial. So you can send us an email to solutions@valispace.com. I'm not sure if I'm sharing the, I think I'll need to stop and start again.
No, you're sharing it. We can see your screen.
Do you see the PowerPoint?
Yes, we do.
Ah, cool. So you can send an email to solution@valispace.com to schedule a demo. And if you're interested, then we can also do a 2-week trial where you have contact with one of our system engineers, and we will help you all the way on the trial to explain how things work, what's the best practices, how you can start, and answer all your questions along the way. Anything else to add, Stefan?
No, I just want to thank you. It was really interesting, even though I've seen the software many times. Every time I follow one of your sessions, there's something new to be learned. So to all participants, thank you so much for joining today. I hope this was valuable. I hope this was interesting. We'll follow up with you via email so you have some of this information available. And we look forward to hearing from you. I hope that the rest of SmallSat has some good surprise for you still. And I look forward to speaking with you next time.
And if you have any other questions, feel free to stay. We still have a couple of minutes, so just unmute yourself or just write on the chat, and I'll be here for a while. Thank you. Thank everyone.